All right, so we're on day 2 of our circles. We got to start at the bottom. The first of the 4 theorems we're going to learn today is at the very bottom of the last page. We didn't finish it because I didn't think we'd have time to do examples, so I didn't want to do that. This theorem says in a circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. What does equidistance mean? Same distance, right? If they are the same distance from the center. So what that means in this picture is that AB and CD are congruent if and only if EG and EF are congruent. My iPad is so slow today. EG is congruent to EF. All right, same thing the other way around. If I know that CD and AB are congruent, then that means I'm going to assume that I know that EG and EF are congruent. So you can go both ways. Everything kind of, or a lot of things we're doing right now are all converses. It works one way, bless you, it works the other way. All right, so let's take that knowledge and go do some examples. The first one says, in circle H, PQ is 3x minus 4 and RS is 14. We want to find X. What do we know about PQ and RS? They're what? They are both chords. Can sit anywhere. What else do I know about them?
They're parallel.
We don't know that.
They're equal.
Why are they equal? I do believe that.
Because TH and HU are, we don't know that. Oh, no, they are.
Why do we know that?
Because TH and HU are equal.
Because?
That's what the theorem says.
Isn't it, hold on. It's easier than you think it's about to be. The reason I know TH and HU.
From the,
right, because it says.
From the center.
Because it says 8.
Oh, okay.
8 and 8. It's just that easy. Yeah, isn't that crazy?
I said they're equal.
What'd you say?
I know, but I wanted you to tell me why you knew they were equal.
Oh, I like the point. I was like,
Okay, I missed the point. Yeah, Wyatt. They're also perpendicular. So I need that perpendicular distance to be equidistant from the center. So that means that if this is 8 and that's 8, these are congruent, which means RS and QP are congruent. Somebody started saying something and I kept talking. Anyone?
I said, or I was gonna ask, is H a midpoint?
H is the center of the circle. We don't know if it's a midpoint. I would argue that T to U is not a straight line. Or yeah, T to U is not a straight line.
Okay, wait, this might be a really stupid question.
It's okay.
But for it to be a midpoint, does the line have to be straight?
Yes.
That's probably the dumbest one ever.
Not a stupid question, but the whole point of a midpoint is that it's in between 2 other points on a straight line. So I would not call U a midpoint, even though it is the same distance from T to U. So I understand your confusion. Let's go ahead and solve this because I know PQ, and I'm even going to write it. I'm going to write PQ is congruent to RS. So let's solve that. Let's do 3x minus 4 equals 14. Add 4 to both sides. I get 3x equals 18, and then x equals 6. Do I need to do anything, or am I good?
You're good.
I'm good.
You can plug it in the check.
I could plug it in and check, right? 3 times 6 is 18. 18 minus 4, is that 14? Yeah.
Yeah, sorry.
Okay.
What did you just say?
It should.
Yeah.
I said, let's plug 6 in for x. So I did 3 times 6 is, what's 3 times 6? 18. And then 18 minus 4 is
14.
Which is what RS is, which should be what PQ is. So we're good. Moving on. All right, next one. It says WX and XY are congruent and they both equal 22, we have to find AB. Why is it helpful that they told me WX and XY are congruent and that they equal 18? Yeah, Braden. That makes AB and AC congruent. Good, so because I know the chords are congruent, that means that they are equidistant from the center. So I'm gonna say AB is congruent to AC, so we can just set them equal. 5x equals 3x plus 4. 2x equals 4, so x equals. Good, am I done?
Yes. No? Oh, you have to find AB. 10.
10. This doesn't happen a lot, but every so often there's multiple choice question that asks you to find something like AB, and we all find X and then we stop and then we don't plug it back in. So make sure to go back all the way and figure out what is actually what we are solving for, like what is actually the goal of this. So I'm gonna do 5 times 2, and that's going to be 10. So my final answer here is 10.
So we need to find AC.
I don't need to find AC, but AC would also be 10 because AB and AC are congruent.
Okay.
All right, that was our first theorem. We've got 3 more to do today. The next one, it says in a circle, the diameter is perpendicular to a chord if and only if it bisects the chord and it bisects the angle. Or the arc, excuse me, the arc. It's bisected. So what this is saying is that a diameter is perpendicular to a chord if and only if it bisects the chord. So that means DE is congruent to EF. All right, they already told us that. And it bisects the arc, which means that DG is congruent to GF. Arc DG is congruent to arc GF. Now, the converse of this is not that like, oh, well, then that means that the arc is congruent, so then the sides are congruent. No, it actually means if I know that these little segments are congruent, I can say that the arcs are congruent, but more importantly, I know that the diameter is what to that chord? What do you say, Andrew? Perpendicular, so I can throw a little right angle in there. So if I know that the diameter AB bisects chord CD, that means because CE and DE are congruent, then that means I've got a right angle at E. Ace?
Do we know, or could we figure out if CB and DB were congruent?
CB and DB are congruent?
Yeah.
I think that we can know that because these two are the same. So then that means that these two must be the same too. That's a good question. Yeah.
Dumb question, but is
Oh, yeah.
actually no, that is such a dumb question. It's all 90 degrees, right?
Yep, all those are 90
Okay, yeah.
degrees. Yep, good question.
Literally all 90 degrees.
It's been a while since you've been here. It's okay.
I'm not saying that was, but there are such
I wanna-
things.
We'll give you a pass on that one.
Appreciate it.
But I'd rather you ask a question that you're like, that's kind of dumb, than to think that it's something else and like not be sure. So I'd rather you be like, I know this might be so stupid. That's all right. Ask it anyway. I will confirm or deny. All right. Next couple problems are using that concept. So this problem says in circle S, measure of arc PQR is 98. So this whole arc right here is 98. Find PQ. What's arc PQ going to be? PQR, this whole gray angle is 98 degrees.
Would that also be 90?
The whole gray angle from P to Q to R is 98.
And then you just ask what R.
RQ is.
It's split in half.
Oh, divided by
Just cut it by 2. Divide it in half. We can cut it in half because it's bisected. If I know that I've got a little perpendicular mark right here between the chord and the diameter, that means PT and TR are congruent, and it means QR and PQ are congruent. So half of that would be 49. All right, that's all I've got there. Are we okay with that?
Yes.
Okay. Next problem says in circle R, find TV. So we want to find this distance right here. It says round to the nearest 100th. All right, we're going to do something that might kind of blow your minds a little bit. I'm going to draw another line that's not in here. I'm going to draw this line right here from T to R.
11.
Why is it 11?
Because it's 5 on that side, 6 on the other side. 5 plus 6 equals
So 5 plus 6 is the radius. So if I draw another radius from T to R, that means that is also 5 plus 6, which is 11. Rosie, I heard you say 90. Why is 90 important?
Is the angle itself 90?
The angle's 90. This angle right here. And this angle right here and that angle right here. Yeah, all of them are 90. I drew that first one though because I want to take this little right triangle and I want to solve him. I know that the radius is 90. What other side do I know? Is it the vertical or the horizontal one?
That's a vertical. Yep.
I actually think we know the 6. I think I know this side right here. 5 is this one right there. That does not relate to my circle or my shape at all. So I think this is 6.
And then we can do the
Pythagorean theorem. So what's my hypotenuse here? What's going to be by itself?
11.
Good. So we'll do x squared plus 6 squared equals 11 squared. We can solve for x. I get x squared plus 36 equals 121. Minus from 36 from both sides. (121 minus 36 is 85. And I'm actually just going to leave that as a radical. You can check and see if you can simplify it down, but like I know 85 divided by 5 is 17. So if I started to do my little factor tree over here, 5 and 17, can I take any two of those down any farther? No. So are there any pairs that I could take out of this radical? No. Now I am not finished with this problem yet because I just found x. I just found t to the middle. I found t to s and I want tv. So that means this is root 85 and then this is root 85. So how much is tv, all of it together? We're not doing root 85 times root 85. We're going to do root 85 plus or times 2. So root 85 plus root 85 is going to be 2 times root 85. And there's no way I can simplify that more. That's as good as that one gets. All right. What kind of questions we have?
You're adding 2 with,
Square roots?
yeah.
Uh-huh.
Is it always going to end up like an answer like that?
So remember that when we add square roots, you can't do anything to the number under the radical. So I only am allowed to add them because they both have a radical 85. But I'm thinking of that I have 1 square root 85 plus another square root 85, and 1 plus 1 is 2. That's what I'm thinking in my head. Okay. I've got one more problem like that. I don't think we're going to do the one next to it. I don't want to do this one. But let's do this one. Let's do the one underneath it. You guys ready to do one more of this type? All right. This says find the value of y. So I've got a little triangle here. What do I know? What can I do to label my picture a little bit better?
You know 11.
I know the 11, so I'm going to bring that over here.
And then you know that there's a 90-degree angle.
You know that there's a
Why is there a 90-degree angle here? And then thus I can put it on my triangle.
Tangent.
Nope, but tangent does often have a right angle. So I love the thought process. Remember the theorem we just learned?
Because there's a radius right there. so it has to-
Perpendicular to the chord.
It's perpendicular to the chord. And I know it's just a radius, but we could extend that line out to be a diameter, right? So because this line BC is bisects AC and CF, then that means it's perpendicular.
We use that. Why?
We are, I will put it over here. Oop, right there. And then I actually think we can do one more thing.
Doesn't AB equal 15?
AB does equal 15. Catherine, why?
Because it's a radius.
Uh-huh. And we know the other radius is BE, which is 15. So that means that this one should also be 15. Very good. So I'm going to finish my little triangle with a 15. All right. And then why is that helpful? What do I do now?
Solve.
Solve using
Pythagorean
Pythagorean theorem.
theorem. My favorite theorem.
My favorite too. Honestly, there's a lot of Pythagorean theorem in this class, so it should be our favorites. A squared plus B squared equals C squared.
That should be my senior quote.
You've got a lot of time between now and then. We'll see if that one sticks, okay?
I make it. After my
Oh,
geometry. After my geometry.
That's not what I meant. You see?
Find me.
That's not at all what I meant.
I make it senior year.
I love that all this is recorded. Because when
I know, you
I
can go
look
back
at the
and watch
notes,
this.
I like listen to
Yeah.
everything you say.
People are gonna be like, who is this girl? Like, nonstop talking. That's me, everybody.
Oh, it's okay.
Just like, I'm gonna be famous. Like, you're freshman in like 5 years, or you're sophomore, my bad.
That's okay.
And I like watch this.
I
I'm
know.
like, who is this weird girl?
Maybe we'll like remake the videos in 5 years.
That's good.
Yeah, if I'm still teaching this for a couple more years, I don't even know what I'm teaching next year. So
That's good on Oscar. Like, what's up, guys?
As no Oscar's not single, but okay, maybe in 5 years.
oh my God.
You guys can take me out of beauty if you get Oscar's number.
Oh my
I
God.
don't even have that. I don't even have that actually.
find out what you're teaching next year.
Hopefully before this end of the school year. I asked to teach the same stuff, but it just depends on who's hired and who stays and who goes if we stay in the same spot.
Yeah, you
Wait,
guys
so
need
what
like
else could you
5
do?
new math teachers.
I heard that would be completing.
I think we're done with that conversation for right now. Let's finish our notes and then we can finish that up, okay? So let's finish this. Can we break down 104?
Yes.
Yes, let's see. Actually, I don't know. I'm gonna think so.
Isn't it like you can
104
go-
divided by 2
104 divided by
is 52. Okay, so we could at least take a 2 out, I'm sure. 52 divided by 2 is 26.
is it 2
And then- Yeah, because I think 26 just breaks down to 2 and 13. So we can only take one pair of 2s out. So that'll be 2 radical 26.
That's my sister.
Hey, hey,
She's like in college.
Sorry to interrupt.
you're so fine.
Oscar, be nice. Come on, family.
Yeah, be nice to your sister.
Oscar, family is always important.
Is that really your sister?
Yes.
Okay.
She's on. She goes to college. She's not home, but like.
Oh, she comes around a lot.
done with school.
Oh, she's done with school.
Yeah.
I was for college and so early.
They
They
also
did
go
like
back.
2 weeks earlier
Do
than
they
we
get-
did.
no,
because
they
they're
don't.
fine. Like my
They
cousins
go
in college go back later than you guys. Or like last.
I'm
week or
not even
something.
moving until the 18th.
Yeah.
The 18th of what?
August is when I move into college and I
That's
start.
moving in
When
like
do
your
you
class.
start?
What your classes start?
Like the 20 something, I bet.
Yeah. I think it might.
22nd,
it might be the
25th.
week After, yeah.
Wait, where are you going?
St. Mary's and everything.
Oh, why don't you not go to that boss lady?
All right. We finished that. We've got one more theorem, 2 more theorems. Let's finish up. Let's focus up. Let's finish, and then we can have all these fun conversations. So before I get into this theorem, I've got a little definition I want to talk about. It says, we've kind of used the words inscribed and circumscribed already, but we're going to use them again. It says, if all of the polygon's vertices lie on the circle, so if the vertices lie on a circle, then that means that polygon is inscribed in the circle. So the example I see right here, this triangle is what we call inscribed in the circle because all the vertices of the triangle are inside the circle. They're on the circle. We call the circle circumscribed around the polygon because it's on the outside. Inscribed is inside, circumscribed is about on the outside. Okay? Everyone gonna laugh about that? LOL. Laugh out loud.
I know you're listening to it.
We're all in 7th grade little boys, aren't we? Such a funny word. Can I move on or are we done laughing at it?
They both look at each other like,
I know. You guys forget that I can see everything. I saw some eyes just kind of dart around. Like, are we gonna laugh about this or are we not gonna laugh about this?
We're not.
You guys you were almost there. You were almost mature enough. And then we decided not to laugh about it. So it's okay, Mace.
It was-
It's not that, it's really not funny.
Not really relevant.
Yes. All right, so let's get into this theorem. It says, if a right triangle is inscribed on a circle, then its hypotenuse is the diameter of the circle. If a right triangle is inscribed in the circle, then that means its hypotenuse is the diameter of the circle. If any triangle is inscribed in a semicircle, that means it must be a right triangle. So the only way for a triangle to be inscribed in a semicircle means that it is a right triangle. Okay? This only works with right angles. Bless you. In order to keep this 90 degrees, I must be on the hypotenuse as my diameter. If I were to stretch this out, then that means I've lost my 90 degrees. So in order to keep my 90 degrees, I need one side to be on the diameter. And then the other side goes about it, all the way around. All right, this is helpful. And this is why we learned about triangles before we got into this unit. It's because now we're gonna do some triangle work, okay? Next problem. I've got this picture goes with these two problems, and then these two problems go with that picture. So I have a triangle that is inscribed in the circle. What do you know about WX? It's the diameter. And if that's the diameter, what do you know about angle Y?
It's,
What'd you say, Rosie? It's a right angle. Why do you know that? Yes. I assume what you said is right. There's been a lot of squeaking that happened. So essentially the theorem we just learned is that if the diameter is the same thing as the hypotenuse, then it's a right angle and vice versa. So that being said, can we find X?
102 plus 2x equals
Where did 102 come from?
90 plus 12.
Good. 90 plus X plus 12 plus X equals 180. And I can do 90 plus 12 is 102
180
minus 102. 39.
Very good.
So that means X is 39. What does that mean angle W is?
51,
Where'd you get 51 from?
39 plus 12.
39 plus 12. Very good. I'm going to write that just in case we forgot. 39 plus 12. You had to plug that in. And what do you say that was? 51?
Yes.
Yes. Okay. That wasn't too hard, was it? All right, let's do the two next to it.
No.
Okay. All right, what do we know about this triangle? The angle at S is 90. Why do you know that? Good. The RT is the diameter, which is also the hypotenuse of this circle. And how does that help me? How am I going to find X? Did you say 2x plus 4x minus 6 equals 90? Yeah, that's fine. You also could add that plus 90 and equal 180, but I don't know if you said that or not, but I'm actually going to do it this way because I would like less numbers if I can. So 2x plus 4x is going to be 6x. I need to add 6 to both sides. Sometimes we make really careless mistakes where you see minus 6 and you minus 6 from both sides. You have to keep the balance. If we have negative 6, we have to add 6. If we have a positive 6, you got to minus 6. 6 divided from 96.
Why is it equal to 90?
Because I said these two angles add up to be 90. Oh no. That's like a basic thing we learned like a long time ago. If this is already 90, then how many degrees are left over between these two?
Oh my God.
Yeah.
So, yeah.
What happened here, what you can do is you can add them all up to equal 180.
I had set up 6x plus 84.
That's fine. You'll get the same thing as me. So you can add them up and set them equal to 180. But what I did is I just was like, let's just jump a step. If I get rid of that right angle, these things must add up to be 90. And what is 96 divided by 6?
16.
16? Okay. So x is 16. What does that make measure of angle 12?
58.
4 times 16 minus 6.
64 minus 6.
Would you say 58?
Pretty sure.
I agree. All right, I've got one more theorem for you. Are you ready for the last theorem and the last 3 problems for today?
Yes.
Okay. Wow, okay. Dang. This last theorem has to do with a quadrilateral that's inscribed in a circle, and it's only inscribed if and only if its opposite angles are supplementary. So in order for this to be inscribed, I need to know that A and C are supplementary. They add up to 180. And I need D and B to be supplementary. They also need to add up to 180. So my little expression is going to say measure of angle A plus measure of angle C equals 180. And then measure of angle D plus measure of angle B equals 180. So those add up to 180. And then these add up to 180. Okay. Opposite angles are set. That's all we say. All right, easy. Let's do the next one. How do I solve?
100 equals 2x and 87 equals
No.
No?
No, 100
Oh, they equal 180.
plus 87 plus 2x equals 8.
Remember, opposite angles are set.
Wait, would it be what? Y plus 87 equals 180?
Caroline, do you have the other one? Opposite angles are set. Y plus 87 equals 180 and 2x plus 100 equals 180. So is this a parallelogram in here?
No.
No, because what do we know about parallelograms? Opposite angles are? Opposite angles are congruent. There we go. Minus 87, do I get 93?
Would Y equal 93 and X equal?
I think X is going to equal 4D, 40.
Yeah, I just forgot this.
It's okay. All right, 2 more. Next one. Find the angle measures. What are we going to do here? Like, give me an equation, please.
3x minus 7 plus 3x. 3y minus 7 plus 3y plus 1.
Okay, pause. 3y minus 7 plus 3y plus 1 equals 180. Could you solve that by itself?
Yeah, you could.
Yeah. So that becomes 6y
Minus 6. 26, like 22.
equals what?
22 times 6. Not even close. 186 divided by 6.
Thank you, Rose. Thank you.
We have to plug it back in. So
We do to find W and to find X.
just plug it in.
3 times 31 minus 7.
86.
93 minus 7. 86. Yeah, what's up?
180 minus 18.
Say that one more time. Yeah, I just didn't hear you. Can you say it again? So to find angle X is this angle right here. Oh, no. We do need to find X though, because the next question says find angle W and we skipped to that. So how do I set up to find angle W? There we go. Mhm. No, you're right. The difference is it says measure of angle X. So that's how I knew it wasn't just a variable. So I'm now going to do that. I'm going to say, okay, let's do 2x plus x plus 18 equals 180. So I get 3x equals whatever 180 minus 18 is. Divided by 3. 54. So what does that make angle W or angle X? Or no, angle W?
No, it's so yeah. Wait, what would we be adding? 18?
Uh-huh.
Oh, you just added something on that. 72.
Uh-huh. That's okay. 72. All right, I've got one more problem. Don't give up on me yet. Thank you. One last problem. This one says, in the diagram below, RSTU is inscribed in circle P. Solve for X and Y and find the measure of each angle. Show clear algebra. All right, let's start going. What things are supplementary? R and T, good. And then U and X. Ooh, now the things that I just highlighted in the same color don't have the same variable. Do we know anything about how 12x and 8x are related? They are, but do we have a rule about those in circles? Do we wish we did? Yeah. Do we not? We don't. So we have to do our supplementary. So let's add them up, set them equal to 180, and then we're going to do some systems of equations to solve. I like to do my x's first. So I'm going to say 8x plus 29y equals 180. And then I'm going to do my other one, 12x plus 21y equals 180. What did you say, Tommy? Bye, Hannah. Did I write it wrong? Bye. Okay, now I can't solve until I cancel anything out. So I like to do elimination. So I'm going to eliminate. How should I do that? What should I do? We will have to subtract, but we're not ready to yet. Caroline? You can make them both 24. What times 8 gives you 24? Good. And what times 12 gives you 24? 2. I do want one of these to be negative. I do not care which one. I'm just going to make this new one that I haven't done yet negative. So we need to distribute -2 to all of them on the bottom, and I need to distribute positive 3 to all of the ones in the top equation. One of them needs to be negative in order to subtract and cancel out. So let's do that. So we know 3 times 8x is going to be 24x plus 3 times 29 is that going to be 87 y. And then 3 times 180, I believe, is 540. Big numbers here. It's all right. We're big kids. We can handle it. All right, bottom one. Now I've got negative 24x. Negative 2 times negative 21 is negative 42y. And then negative 2 times 180 is negative 360. This whole thing is helpful because my 24x's cancel, and I can do 87 minus 42, and I get 45x. And I can do 540 minus 360, which I think is just 180. Yep. Good. Divide by 45, and y is going to equal 4. We can plug that back in now to find our x. Doesn't matter which equation you plug it into. I like to pick one of my original ones, one of my purple ones. So I'll say, okay, 12x plus 21 times 4 equals 180. I know 21 times 4 is going to be 84. Minus 84 from both sides, and I get, I think, 96. And then divide by 12, and I get 8. Perfect. And you just need to find x and y. Oh, wait, no, it says find the measure of each angle. I lied. Can you plug those in really quick? All right, so 8 times 8 is going to be 64. And then 29 times 8 is going to be, oh no, y is not 8, y is 4. Okay, that was good. 29 times 4, that's better, is 116. Now I gotta do 12 times 8 because 8 is x. So that's 96. And then 21 times 4 because 4 is y is 84. And then we could do a little check for ourselves. Are the two ones that are across from each other, are they supplementary? Yeah. 116 and 64 are both sup, so are 96 and 84. The other check you can do is all of them should add up to 360, and we could do that. We could plug them all in and say, do they add up to 360? The answer should be yes. All right, you have a few minutes left in class. Your homework is this. It's the next pages of your packet. It is 2 and a little bit. So please make sure you do all of the page circles part 2, all of its back, and then there's one little problem on the next page. You need to do essentially 2.5 sides. Please nod with me if you know you have 2.5 sides for homework. How many sides do you have for homework? 2.5. 2.5. Yeah? Okay. I don't see you till, I don't see you till Thursday. How fun. You have lots of time to do this homework. All right, you guys done with my screen? All right.
Ms. White, am I good to go?
You are good to go, Catherine. Feel better.
Okay, thank you.